In part 6 of our lesson on the graphs of sine and cosine, we're going to do a summary of graphing y equals a sine of bx or y equals a cosine of bx. Now, as we've learned in previous lessons, a is the coefficient of the trig function and b will be the coefficient of the argument of the function. So the amplitude of the function will be absolute value of a, which means the range will go from negative absolute value of a to absolute value of a. So what that means is even if a is negative, when you take its absolute value, of course, that makes it positive. That keeps this first term negative and the second term here positive, which satisfies the interval notation order that's required. The period is going to be 2 pi divided by b, and we can find what's called the inequality for the new cycle of the graph by solving this inequality. 0 is less than or equal to b times x, which is less than or equal to 2 pi. And where this comes from is the fact that a normal cycle for sine and cosine goes from 0 to 2 pi. But we know that the b coefficient of the argument is going to affect the horizontal stretch or compression. So solving this inequality will let us know where to start and end the new cycle. So let's get started with this example where we have to sketch one complete period of the graph of y equals 4 cosine of 2/3 x. Now the domain of every sine and cosine function is negative infinity to positive infinity, which means we can plug in all the values of x going in the positive direction and all the values of x going in the negative direction. To find the period, we know that we're going to do 2 pi over b. Remember that b is the coefficient of the argument, so b is equal to 2/3. And we know that dividing 2 pi by 2/3 is the same as multiplying by 3/2. The 2's are going to cancel, and we're left with 3 pi. So that tells us that the time it takes to get from the beginning of the graph to the end of the one complete period of the graph is going to be 3 pi. The amplitude comes from the absolute value of a, and a is the coefficient of the trig function, so this is the absolute value of 4, which is equal to 4. Now the range, we know that an unaltered cosine graph would have a range of -1 to 1, and then we know that it will be affected by the amplitude, which is equal to 4, and that is going to turn the range of our graph into -4 to 4. And that's the opposite of the absolute value of a, comma, absolute value of a. Next, we have to solve the inequality for the new cycle. So we know that means we have to do 0 is less than or equal to bx is less than or equal to 2 pi. So we're solving 0 less than or equal to 2/3 x, which is less than or equal to 2 pi. Now to get the x by itself, we see that we're going to need to multiply by the reciprocal, which is 3/2. So we have to make sure we do that to all three pieces of the inequality. And we're going to get 0 is less than or equal to x is less than or equal to 3 pi. So this inequality tells us where the cycle of our one complete period will start and end. So it will start at x equals 0 and it will end at x equals 3 pi. Now you may think that we knew that already because the period was 3 pi, but in the very next section we do, you're going to learn about horizontal shifts of the function, and solving this inequality will help you find the starting and ending point of the graph even when you have horizontal shifts. So I'm teaching you one method that will let you graph every single graph in all of trigonometry. Next, we want to plot the 5 key points of the graph. 5 key points means there's 4 intervals because there's an interval between each of the 5 key points. We know we're going to start at 0. We know we're going to end at 3 pi. And now we need to break that interval up into 4 equal pieces to give us the 5 key points. So first, we'll find the midpoint of 0 and 3 pi. Now to find the midpoint of any two values, you add them up and divide by 2. So rather than divide by 2, I'm going to choose to multiply by 1/2. So I'm going to take 1/2 of 0 plus 3 pi, which we know is going to be 3 pi over 2. So that's the x value of our middle point of our 5 key points. Now to find the quarter of the way point, we need the midpoint of the start and the midpoint. So we're going to add those up and divide by 2, which of course I'm going to multiply times 1/2. So we have 1/2 of 0 plus 3 pi over 2, which is going to be 3 pi over 4. So that is the x-coordinate of the second point, which is the quarter point of our graph. The only one left to find is the fourth point, which is the 3/4 of the way point, and it will be the midpoint between the midpoint and the end point. So we'll add those up and divide by 2. So 1/2 of 3 pi over 2 plus. Now I know it would be 3 pi that goes there, but I see I need a denominator of 2, so I'm going to write it as 6 pi over 2 so that I can more quickly do this addition. We have 3 pi over 2 plus 6 pi over 2. We know that's going to be 9 pi over 2. And half of 9 pi over 2 is 9 pi over 4. So now let's think about our expected y values that we're going to get on the graph. We know that cosine always starts at its maximum, and if you start from the unaltered cosine graph and think about what we are calling the expected y values, we know cosine starts at 1, then goes to 0, then goes to -1, goes to 0, and then ends at 1. Cosine always goes max, root, min, root, max. Now we know that our function is y equals 4 times the cosine of 2/3 x, which means that all of the y values are going to be multiplied by a, which in this case is equal to 4. So then that means the y value that was 1 is now going to be 4. 0 times 4 is still 0. Negative 1 times 4 is negative 4. 0 times 4 is 0. And 1 times 4 is 4. It's a good idea to check every possible value that you're getting and make sure that it's correct. But on your exams, I will require that you check at least one and show me the work of your doing the checking. Now, I also strongly suggest that you don't check one of the roots because you can have the graph flipped upside down and the roots would still be right. So in this case, maybe we would choose to do the midpoint. It could be anything. It could be the start point, the midpoint, or the end point. Let's say we're going to do the midpoint. And we're going to plug that into our function and make sure that we're getting negative 4. So if we plug our x value in, we have 3 pi over 2. That's going to have to go in for x in the function. So then this would be 4 times the cosine of 2/3 times 3 pi over 2, which is 4 times the cosine. Well, let's look at the argument. The 2's are going to cancel, the 3's are going to cancel, and the argument becomes pi. We know that the cosine of pi is negative 1, and 4 times negative 1 is equal to negative 4. So our result checked out with what we expected it to be. So we're feeling pretty confident about making our graph. Now, in order to plot the points on the graph, you have to think about the scale of the x-axis and the scale of the y-axis. The x values are 0, 3 pi over 4, 3 pi over 2, 9 pi over 4, and 3 pi. One of the suggestions that I will make to you is that you give them all a common denominator, and it will be much easier for you to make your graph. So it's clear that our common denominator would be 4. Now the starting value of 0, we don't need to change. It's going to be 0. 3 pi over 4, we can just bring it right over. It already has the common denominator. Now 3 pi over 2, we know is going to be 6 pi over 4. And 3 pi would be 12 pi over 4. And now you can double check that every interval is the same. You're going up each time by 3 pi over 4. And now we have our x and y coordinates of each point on our graph, and we're ready to go up to our graph and plot these points. Our x scale, as we said a minute ago, is going to go by 3 pi over 4. So we get all our x values in there. And you're welcome to write them with their common denominator, or if you prefer to write the reduced form, then you could call this 3 pi over 4, 3 pi over 2, 9 pi over 4, and 3 pi. That's fine. Your y scale looks like it's going to go by ones. We know we have to go up to positive 4, and we're going to have to go down to negative 4. And now we're ready to plot those 5 key values. We've got 0, 4, 3 pi over 4, 0, 6 pi over 4, negative 4, 9 pi over 4, 0, and 12 pi over 4, 4. Connect the key values with the smooth curves. And there's our graph. Next, we have to solve an equation to find all the x-intercepts and then use it to find 3 roots. Remember, x-intercepts and roots are the same thing. Now, the way we'll find the x-intercepts or find the roots is we'll solve an equation where we set the argument of the function equal to the normal place where all the roots are. Now, the argument of our function in this case is 2/3 x and if you look back in your notes to where we made that summary chart for sine and cosine, you'll see that the roots for cosine normally occur at pi over 2 plus n pi. So the first thing we'll do is get a common denominator over here on the right hand side. So this becomes 2/3 x is equal to, now we know our common denominator is 2, so we have pi plus, we know that for this to have a denominator of 2, we have to multiply it times 2 over 2, and so it becomes 2n pi. Now we're going to multiply each side by 3/2. And we see that we're going to get x is equal to 3 pi plus 6n pi over 4. And this is our equation which will find all the roots. Now we're going to use that equation to find 3 roots. Remember that n is an integer, so we're going to be plugging in for n to find out the value of the root. So we can pick any integer we want, say -1, 0, and 1. That would be 3 integers. And then we will be plugging into the formula where x is equal to 3 pi plus 6n pi over 4. So if n is equal to -1, we put that -1 in for n, we'll get 3 pi. Now 6 times -1 would be minus 6 pi over 4, which works out to be -3 pi over 4. If we plug 0 in for n, we know that will wipe this term out, and we're just going to get 3 pi over 4. And if we plug in a 1 for n, we're going to get 3 pi plus 6 pi over 4. And that works out to be 9 pi over 4. And that's how we could go on and on with more and more integers if we wanted to find more roots of the function. And you can see in the one cycle that we did, we had a root at 3 pi over 4 and we had a root at 9 pi over 4.